Okay, so the last step in the weak acid and a strong base titration is looking at after the equivalence point. So think of it kind of, on a logical sense that, well, now we've surpassed equivalence point, so we have more strong base in there, okay? Therefore, our strong base should be dominating. All right, so if we look at, I'm going to do letter G from the example. Okay, if I have 75 mils of our 0.1 molar NaOH being added to our acetic acid, right, what does that look like? Okay, so again, right, that very first step, looking at what we have left over, we have our OH just going to interact with our acetic acid to form, so make sure you have room. We're going to form our acetate ion and H2O. Okay, so looking at this, right, we want to see our before and after moles or millimoles. So, right, before with the OH, we have 0.1 times the 75 mils, so we're going to be left with 7.5 millimoles. Okay, for our acetic acid, right, that hasn't been changing, so we have 5 millimoles of acetic acid. Okay, so we're going to do our after. Okay, now instead, on which has been different, right, we've always had acetic acid left over, but in this case, our acetic acid is the limiting. Okay, and at the end of this, we have 2.5 millimoles of OH remaining and 5 millimoles of our acetate ion. Okay, but what's important to notice, guys, is that the acetate ion, yes, we had looked at it in the previous problem, did act as a base, but it's such a weak base, right? While on the other hand, our OH, right, comes from a strong base. Therefore, the strong base is going to trump this base, right, this conjugate base. Therefore, all we're worried about is our OH. Okay, so just like in the strong acid, strong base problem, when we do have a strong base left over, or a strong acid, right, we just get to plug it into our equation. We get to find the concentration. So first, we're going to find the concentration of OH. So we have 2.5 millimoles over our total solution, which is the 50 mils of acetic acid plus the 75 mils of this base, right, which ends up giving us a 0.02 molar solution. Okay, so now we can plug it in for the negative log of 0.02 is going to give us 1.70. But remember, right, this is the POH, so 14 minus 1.70 should give you 12.30. And this should make sense, right? Our pH should be basic, because we have a lot more basic solution present than we do weak acid. We've surpassed equivalence point, we have more base, therefore our pH is basic. So once you've reached an equivalence point in a weak acid strong base, we can just look at how much OH we have. All right, so that wraps up our weak acid and strong base titration.